Next, we are going to understand magnetic field on the axis of a circular current loop. It's very important board examination point of view. They will ask for 5 marks. Very important. Listen carefully and very easy also. These expressions are very important for a competitive exam also. Okay, so listen. Magnetic field on the axis of a circular current loop. So I am taking one circular current. Okay, this is a circular loop through which what happen, current is flowing. Assume, consider current carrying loop, circular current carrying loop. Okay, due to this loop, right, from its center of the loop where? Here center of the loop. From center of the loop to, okay, so on its axis at point B, okay, at certain particular point, this x axis. Let us consider this coil is in a which plane? YZ plane. You consider this coil is in which plane? YZ plane. This is a this stick is okay, is there in a which axis? Along which axis? X axis. Okay, now we are going to understand so what is the magnetic field due to the current carrying coil at P point, on the axis. Okay, so at which point? At P point on the axis from its center. So at which point what is a magnetic field? For that we are applying Biot-Savart law. For Biot-Savart law we should consider what current carrying element. Okay, so in this coil current is flowing which direction? So anti-clockwise direction. This is a anti-clockwise direction. Current is flowing anti-clockwise direction. Now consider current carrying element. This is a current carrying element. So consider current carrying element. Current carrying element at DL bar. DL bar direction, draw tangent here. Okay, so it is a DL bar direction. Okay, and also you should draw about a perpendicular distance. Draw the distance line joining from DL element to point P. Okay, line joining from DL element to point P. This is a line joining from DL element to point P. Correct? So this is a DL bar. This is a DL bar. Correct? Then I am line joining from the DL element to point P. Okay, then DL bar and R bar. How both are? Look. So this is a DL bar. Okay, this is R bar. Okay, DL bar and R bar. How both are? Perpendicular to each other. Then angle between, okay, so DL, this is a, look here, this is a, my finger or this strip is a DL bar. Okay, now this is R. Angle between DL bar and R bar how much here? 90 degree, okay. This is DL and this is R. Angle between DL bar and R bar how much? 90 degree. Okay, so radius of the coil is R. From the center at x distance you are calculating magnetic field. Okay, the distance from this DL element to point B, how much distance? Apply the Pythagoras theorem, you will get what? Under root of R square plus X square. Distance from DL element to point B. Okay, angle between DL bar and R bar how much it is? 90 degree. Okay, then so from Biot-Savart law, what is the Biot-Savart law? dB is equal to mu naught by 4 pi I dl sin theta. Theta is nothing but angle between DL bar and R bar. How much it is? 90 degree. Okay, I dl sin 90 by R square. R square means the distance from DL element to point B. How much it is? Under root of R square plus X square. Under root of R square plus X square whole square. Okay, then simplify means what will get? dB is equal to mu naught by 4 pi I dl by, okay, under root of R square plus X square whole square means R square plus X square. By symmetry, symmetry means the circular coil. The circular coil from its center, okay, this is above off, this is below off. Above off, below off. At each and every point you can observe the, okay, at this point, first at this point, okay, due to this current carrying element at point P, what is the magnetic field? Okay, so current due to current carrying, okay, element at a point P, what is the magnetic field? Which direction magnetic field is acted? Okay, so we are going to find that this is a current carrying conductor. Current is flowing which direction? Okay, in this direction current is flowing. Hold current carrying conductor. Okay, along the current direction, okay, stretch your thumb, curl your fingers, understand? Okay, so it's a current direction, curl your fingers, okay, at that point you can imagine, right, at that point you can imagine, so that is the direction of magnetic field, at this point direction of magnetic field, okay, so it is a current carrying conductor, at this point P, what is the direction of magnetic field? due to this current carrying element at point P, what is the direction of magnetic field? Which direction that is acting? Okay, so which direction that is acting? Correct. So due to this one, right? Hold current. Okay, like this. At that point P, imagine. At that point P, imagine this fingers. Fingers is what direction of magnetic field. Okay. So this is the direction of current. Understand? This is the direction of current. Call your fingers. Call your fingers. At that point P, imagine that is a. So what is the direction of a magnetic field? The direction of magnetic field is what? So like this. This is dB is a direction of magnetic field. Okay. Due to this current carrying element at point P. Like that, each and every point what happen? The dB direction is okay, keep on changes. At this point, what is the direction of magnetic field? Along this line will come. Now this dB has two components, x-axis component and y-axis component. Suppose let us assume the angle between this what is it, r and this axis theta you consider. Okay, so vertical opposite angles are same. This is theta. Okay, this is theta. Then angle between this dB and this which one, r bar. Okay, dB direction is what? dl bar direction and r bar direction. dl bar cross r bar direction is d bar direction, and dB is which is perpendicular to dl bar and r bar. dB is which is perpendicular to which one? R bar. Okay, and dl bar. Okay, dB which is perpendicular to r bar means angle between this dB and this r bar. How much it is? 90. This is theta means this is how much? 90 minus theta. And this x-axis and this y-axis, this is 90 minus theta means what about this angle? Theta. Correct? Huh? So these are the components dB, right? So along the y-axis, these are the components what will get? dB cos theta. Along x-axis, what is dB cos of 90 minus theta? What is the dB sin theta? Along the x-axis, the dB sin theta. Along the y-axis, dB cos theta. By the symmetry, okay, above the coil, that dB, okay, magnetic field is what? So above dB cos theta. Below the coil, each and every point magnetic field is what? dB cos theta downward. By the symmetry, the resultant magnetic field on the y-axis, how much it is? Plus dB cos theta minus dB cos theta. Suppose it is plus 2 minus 2. How much it is? Resultant magnetic field at point B, how much? 0. Okay, due to which one? Okay, due to current carrying element, this current carrying conductor, okay, due to current carrying conductor, magnetic field along the y-axis how much? 0. Now, due to this current carrying conductor, at this point B, what is the magnetic field? Okay, along the x-axis, each and every point, at this point, what is the magnetic field in this direction? Okay, at this point also this direction, at this point magnetic field this direction, at this point magnetic field direction. Means along the x-axis, what happens? Magnetic field is not equal to 0. Each and every above or below of the magnetic field is which is away from the center, which is away from the center. Now, so that by Savart law, we understood it. Okay, till here dB is equal to V0 by 4 pi IDL by r square plus x square. By symmetry, so sigma dB cos theta, sigma dB cos theta, how much it is? 0. By symmetry. Okay, so y-axis, positive y-axis, how much it is there? Okay, negative y-axis also same thing. Same component will take place, and all at this point dB cos theta along y-axis. At this point dB cos theta. At this point dB cos theta. From here onwards dB cos theta downward, dB cos theta downward. Till here it is downward. Again upward. Then along the y-axis, the result magnetic field direction along the y-axis how much? 0. This sigma dB cos theta means 0. Next sigma dB sin theta is what? Which is not equal to 0. Sigma dB sin theta which is not equal to 0. Why? Because at this point what is magnetic field? Along this direction. At this point what is magnetic field? In this direction. At this point what is magnetic field? In this direction. At this point what is the magnetic field? In this direction along the x-axis. At this point magnetic field is what? Along this direction. Correct? Okay. Now, so it is a V is equal to sigma dB. Then sigma dB sin theta not equal to 0. Sigma dB cos theta is equal to 0. Nothing but resultant magnetic field direction to current carrying coil along which axis acting? Along the positive x-axis acting here. That means, so B is equal to integration dB sin theta, that is equal to integration mu naught by 4 pi IDL by r square plus x square sin theta. Okay, so B is equal to integration dB sin theta, that is equal to, so integration, why integration? So due to current carrying element, due to small element, so we got magnetic field this is. Okay, so then we want for whole current carrying loop, what is the magnetic field at point B? Okay, integration. Okay, integration means sigma, summation of all these elements. Okay, so due to the summation of all these elements, current carrying elements, what is the magnetic field direction at point B? That is what B is equal to integration dB sin theta is equal to integration. Substitute dB value here, mu naught by 4 pi I dl by r square plus x square sin theta, that component dB sin theta component. That is equal to integration mu naught by 4 pi. So integration mu naught by 4 pi I dl by r square plus x square. What is the sin theta in this triangle? Okay, in this right angle triangle, what is sin theta? R by under root of r square plus x square. Sin theta is what? R by under root of r square plus x square. Then V is equal to what? Mu naught by 4 pi. So I what is that? So mu naught by 4 pi. So sin theta substituted. Sin theta r by under root of r square plus x square will be substituted. So take it out. That mu naught by 4 pi I r by r square plus x square. So 1 by 2. Okay, r square plus x square here. R square plus x square whole power 1 by 2 is there. 1 into that base are equivalent. Okay, so then multiplying means power should be added. Then r square plus x square whole power 3 by 2. Integration dl. Integration dl is there. Integration dl means circumference. Circumference of the coil. How much it is? 2 pi r. Integration dl is nothing but complete length of the coil. How much it is? 2 pi r. Therefore, so what is the B here? Mu naught I r by 4 pi into r square plus x square whole power 3 by 2. Integration dl is 2 pi r. So pi get cancelled. 2 1s are 2 2s are 4. Then mu naught I r into r square. Mu naught I r square by 2 into r square plus x square whole power 3 by 2. Mu naught I r square by 2 into r square plus x square whole power 3 by 2. So what is the direction of this magnetic field? We can determine the direction of magnetic field now. By using which one? By using which one? Okay, so right hand thumb rule. By using right hand thumb rule, we can determine the direction of magnetic field. Okay, so how to determine? So it is a current carrying coil. Suppose current is in anti-clockwise direction like this. When a current is anti-clockwise direction, okay, so this is your palm. Okay, this is your palm. So palm should be stretched along the current direction. Palm should be stretched along the current direction. And which direction thumb is opened? That is the direction of magnetic field. Which direction thumb is opened? That is the direction of magnetic field. Okay, due to this current carrying coil, okay, which direction the thumb is opened? Okay, thumb is opened along the positive x-axis. That is the direction of magnetic field. Okay, anywhere. Okay, suppose at this point, what is the direction of magnetic field? At this, due to this element. Okay, call here. Okay, stretch. Okay, palm should be stretched along the current direction. Which direction thumb is open? That is the direction of magnetic field. Anywhere you can check it. The direction of magnetic field is what? Okay, so the resultant direction of magnetic field is what? Along the positive x-axis. Correct? So or else you can find out what this dl bar cross r bar. Dl bar is along which axis? Along okay, so z axis. R bar is in which plane? So xy plane. Correct? Na? So r bar is in which plane? Xy plane. Simplify from that also. You will get what? So along the positive x-axis, you will get the direction of a magnetic field. Correct? Na? Right? Okay, I hope you understand magnetic field due to the current carrying coil at one point in the axle is what? B is equal to mu naught I r square by 2 into r square plus x square whole power 3 by 2. Direction can be determined using right hand thumb rule. So what is this figure? This figure is what? So the one current carrying coil is like this, it is there. Current carrying coil like this, it is there. Okay, current is flowing in anti-clockwise direction. Suppose the current carrying coil is placed like this. Okay, now at this point, what is the direction of magnetic field? Okay, so this palm is placed along what? Along the current direction. Now thumb is what? Towards which one? Okay, that is a clockwise direction. Okay, here. So at this point, what happened? At this point, so palm is placed along the current direction. Okay, and thumb is opened along which direction? Upward it is. Correct? Na? Okay, here the palm is placed along the current direction and what is it? Open your thumb finger. So open your thumb finger, that the thumb finger is along which direction? Anti-clockwise direction. Okay, here. So here is what? The palm is placed along the current direction. This thumb is what? Along, okay, so clockwise direction or okay, upward direction. Means based on this direction of these circular lines, we can determine the direction of what? Magnetic field. Here, the circular lines are what? Clockwise. Clockwise means okay, south pole of the magnet. Okay, so this is what we anti-clockwise direction. Anti-clockwise direction means what happen? So north pole. Anti-clockwise direction means what? North pole. If the here also same thing, anti-clockwise direction means north pole. Okay, clockwise direction means what? South pole. Okay, means this current carrying coil is acts like what is magnetic dipole. This we'll discuss in next classes. I hope understood. Okay, magnetic field on the axis of circular current loop is what? Okay, B is equal mu naught I r square by 2 into r square plus x square whole power 3 by 2. This is a very important expression. Okay, very easy also. Okay, I hope you understand the direction of so magnetic field on the axis of a circular current loop. You should imagine 3D. Okay, in this situation, okay, how the direction of magnetic field is along the positive x-axis. Okay, is very easy. This is a situation, right? So the same figure I am taking like this. Better. Okay, easy way you can understand. So it is in a YZ plane. It is x-axis. Okay, na? Now, so current is anti-clockwise direction. Current is in a anti-clockwise direction. Now place your palm along which one? Current direction. Now which direction? Open thumb finger. That is a direction of along the positive x-axis. This is what a direction of magnetic field. Okay. Suppose current is in a clockwise direction means direction of magnetic field is what? Along the negative x-axis. I hope understood. The coil is in which plane? YZ plane. Now this is a strip is along which axis? Which axis? X-axis. At this point we are calculating the magnetic field. Okay, current is anti-clockwise direction. Now by using right hand thumb rule, we are determine the direction of magnetic force. Okay, by using which rule we can determine the direction of magnetic field of the current carrying coil? By using right hand thumb rule. Okay, that is what is a coil, current carrying coil. So it is a strip, correct? So along x-axis, at this point we are calculating the magnetic field. Now this is which direction current is flowing? Anti-clockwise direction current is flowing. Okay, so place your palm along the current direction, stretch your thumb finger. Okay, which direction thumb is opened? That is the direction of what? Magnetic field direction. That is which direction? Along the positive x-axis, I cap plus I cap. Correct na? Okay, if current is in clockwise direction means okay, so place your thumb finger along the current direction, and which direction thumb finger is open? That is the direction of what? Magnetic field. Correct? Okay, I hope you understood. Okay, this is the direction of magnetic field. When the current is in anti-clockwise direction, when current is clockwise direction, this is the direction of magnetic field. Correct na? Okay, same thing, same. That is represented here dB. After resolution of components by help of symmetry along y-axis dB value 0. Okay, along y-axis that magnetic field is 0. Only x-axis what happened? That magnetic field is there. Okay, that is what dB is 90. It's the complete resonant magnetic field we calculated. That is a mu naught I r square by 2 into r square plus x square whole power 3 by 2. That is what the direction of magnetic field. Correct? Okay, thank you. Okay, students, few special cases are there in magnetic field on the axis of a circular current loop. It's a very important application of Biot-Savartla. Okay, case 1. At the center of a coil. At the center of coil means okay. So x is what? In the mu naught I r square by 2 into r square plus x square whole power 3 by 2. What is x here? Distance from center of the coil to at where you are calculating the magnetic field. Okay. At center means what is x? 0. Okay, substitute x is equal to 0 here. You will get what? B mu naught I r square by 2 into r square whole power 3 by 2. X is 0. R square whole power 3 by 2 means 2 to get cancelled. 2 r cube. Okay, r square by r cube means r by r. Then mu naught I by 2r. Means magnetic field to the current carrying coil at center is what? Mu naught by 2r. Very important. Okay, magnetic field to the current carrying coil at center mu naught by 2r. Mu naught is magnetic permeability, I is current flowing through it, r is the radius of the coil. Case 2. If the coil has n number of turns, the coil has n number of turns. In this case, magnetic field induction to the current carrying coil at center is how much? N mu naught n I by 2r. One turn to mu naught I by 2r, n number of turns, n mu naught I by 2r. At one point, not at center, suppose you are calculating magnetic field induction at not center. At one point you are calculating magnetic field. In that case, what happen? Coil has n number of turns. B is equal to mu naught ni r square or n into mu naught I r square by 2 into r square plus x square whole power 3 by 2. Due to one turn, mu naught I r square by 2 into r square plus x square whole power 3 by 2. Due to n number of turns, B is n mu naught I r square by 2 into r square plus x square whole power 3 by 2. What is r here? Radius of the coil. At center of different coils. Different coils means suppose one circular arc like this is there. What is the angle of circular arc? Angle how much? Pi. Okay, current is flowing in this direction. Then what is magnetic field direction at this center? Okay, so mu naught I by 2r. Okay, that is what at center. When for complete circle, for pi angle, okay, so what is the magnetic field direction? Okay, that is pi by 2 pi into mu naught I by 2r. Okay, for 2 pi angle means complete circle, 2 pi by 2 pi, cancel mu naught I by 2r will get it. For pi angle, so pi by 2 pi, like your marks, out of 100, suppose 90 marks you got, 90 by 100, like that, na? Nothing matter. For whole 2 pi, okay, for circular complete angle, how much 2 pi? For whole 2 pi, okay, how much angle? For this angle, what is the magnetic field? Mu naught I by 2r. For complete 2 pi, 2 pi by 2 pi. For complete circular coil means 2 pi you can substitute. 2 pi by 2 pi 1, mu naught I by 2r. Okay, semicircular means pi by 2 pi. Pi get cancelled, mu naught by 4r. Okay, magnetic field direction of current carrying coil at center is mu naught by 2r. For half of the coil, semicircular coil, by half means mu naught I by 4r, correct na? So mu naught I by 2r into, so pi is what here? Okay, so for the at circular this angle of circular at this angular circular arc, what is the magnetic field direction at center? That is mu naught I by 2r into pi by 2 pi. You can understood. Right? So this is very, very important. They will give a circular arc. This circular arc angle should be taken radian, not degree. Why radian? Denominator should be in a radian. That's why this circular angle should circular angular arc should be taken a radian. This is very important in a board examination point of view, or else a competitive examination point of view. Very, very important. Keep in your mind. Next, come to the example number 1. Consider a tightly wound, okay, 100 ton coil of radius 10 cm carrying a current of 1 ampere. What is the magnitude of the magnetic field at the center of the coil? How many number of turns given here? 100 number of turns given. Radius how much given? 10 cm. 10 cm means how much? 10 in 10 power minus 2 meter. Then so this is what current carrying a circular coil. Magnetic field direction of current carrying coil, we are asking at center. So just to be understood, if for n number of turns magnetic field direction of current carrying coil at center is how much? Mu naught n by 2r. Where n is number of turns. Mu naught is magnetic permeability for free space. I is current flowing through coil. R is the radius of the coil. Substitute here. Mu naught 4 pi 10 power minus 7. Number of turns, okay, 100. 10 square means 100. Current how much? 1 ampere. By 2 into, what is R here? 10 centimeter. 10 centimeter means 10 in 10 power minus 2. That is what? 10 power minus 1. Then B is equal, simplify this one, 2 to 1 is 2 to the 4, 2 pi into 10 power minus 4. Okay, that is pi value 3.14. 3.14 into 2, 6.28. 6.28 in 10 power minus 4 Tesla. Correct na? Next, come to the example number 2. So in this configuration, what is the magnetic field direction to the, okay, first is number 1 segment at center, okay, number 2 segment at O, number 3 segment at O. Okay, this due to first segment, what is the magnetic field direction at O? Okay, for the DL bar cross R bar, you can check it. So DL bar is along x-axis. R is what? Distance from DL element to point O. That is also along which axis? Along x-axis. I cap cross I cap, how much it is? 0. Then the magnetic field direction to the this first wire at O is how much? 0. Okay, that means magnetic field direction due to the current carrying wire on its axis how much? 0. This is very important point. Magnetic field direction to the current carrying wire on its axis 0. Okay, similarly third wire also you can take up this third wire. So what is the current is which direction it is flowing? So along the positive x-axis. Okay, length of the element along the positive x-axis. Now distance from length of the element to point O, which axis? Negative x-axis. Now angle between the DL bar and R bar is how much? 180 degree. DL bar cross R bar, okay, so sin 180 is a 0. Correct? Huh? So nothing but, so B magnetic field direction to the third wire at O how much? 0. Similarly, magnetic field direction to the second segment at O, how much it is? It is a semicircular shape. Correct? Na? Magnetic field direction to semicircular. Okay. At O, what is the circular arc angle? Pi. Complete circle means 2 pi. Okay. Due to semicircular arc, what is the angle here? Pi. Then so mu naught I by 2r into. So what is the pi here? Pi by 2 pi. Pi get cancelled. How much it is? Mu naught I by 2r. What is the direction of magnetic field? Direction of magnetic field. So just now we understood direction of magnetic field. Right? You place your palm along which direction? Current direction. Okay, so current direction. Thumb is along which direction? Okay, perpendicular into the board. Okay, perpendicular into the board means, okay, cross mark we can represent. Okay, perpendicular into the board or along the negative z axis. Suppose it is x and it is y, means this is what along the z axis. It is x, y, so it is what along the negative z axis, means into the board. So place your palm along the current direction, and so which direction thumb is open, that is the direction of what? So magnetic field here. In this configuration, okay, due to first segment, at above what is the magnetic field? Length of the element and r, both are in the same direction. Both are in the same direction means, so dB bar is equal mu naught by 4 pi I dl bar cross r bar by r cube. dl bar is this is a dl bar, this is a r bar. dl bar cross r bar how much? 0. Okay, means due to first segment, what is the magnetic field extended at point O? 0. Means any case magnetic field extended to the current carrying wire on its axis how much? 0. For first wire on its axis, third wire also on its axis. Okay, due to third segment, what is the magnetic field extension? So dl bar is along the positive x axis, r bar is along which axis? Negative x axis. Then dl bar cross r bar how much? 0. Okay, only due to this segment. What is it due to this segment? What is the magnetic field extension at point O? So at point O, magnetic field extension to this segment is at point O is okay, B2O is what is semicircular again, mu naught by 4. Correct? What is the direction? Direction is, okay, place your palm along the current direction. Which direction thumb is open? That is the direction of what? Magnetic field. So which direction thumb is open? That is the direction of magnetic field. Correct? So that which direction open? That is along perpendicular out of the board, means positive z axis. This is a negative z axis, it is a positive z axis. It is into the board, it is what? Out of the board. This dot represent what? Out of the board. I hope you understood. Okay, by using this example, you understand how to calculate the direction of magnetic field. And so magnetic field due to the current carrying wire on its axis, magnetic field due to the current carrying conductor on its axis is what? 0. Correct? Understood now? Right? Once again, you revise all the videos. Okay, don't skip any video. Watch carefully and try to understand and complete the given assignment. Thank you.